So this is the last example that we have to cover in chapter 7, and this will be the last lecture in chapter 7. We're going to do one more example where we have to find a raw score. Whoops. There we go. Okay. So body mass index, BMI, is a measure of body fat based on a person's height and weight. The BMI of an American female is approximately normally distributed with a mean of 28.7 and a standard deviation of 1.4. A female is considered obese if her BMI is within the top 18% of the distribution. What's the minimum BMI of a female to be considered obese? Let's do what I've been telling you the last few lectures. Do not try to just pick up the calculator and answer the question. I'm not even going to look at the question. I'm ignoring this last sentence for now where the question is. First, understand the population. The population of interest is are American females, and we're studying their BMI, body mass index. That's the variable of interest. We know BMI is normally distributed or approximately normally distributed with a mean of 28.7 and a standard deviation of 1.4. We also have one more piece of information. A female is considered obese if her BMI is within the top 18% of the distribution. We'll go to the question after. So do what we've normally been doing in all these other questions. Identify the variable of interest. So X is BMI or body mass index. BMI is approximately normal. So we're picturing that bell-shaped curve. There's a mean or a mu of 28.7 and a standard deviation or sigma is 1.4. We also know that a female is considered obese if her BMI is in the top 18% of the distribution. So why don't we make a sketch and then we'll go to the question. So based on what I jotted down on the left here, I know that BMI is normal. So I'm going to sketch my normal curve. I know the average or the mean BMI is equal to 28.7. So that's going to go in the center. And I know a female is considered obese if her BMI is in the top 18% of the distribution. So let's say here, this is the cutoff for the top 18% of the distribution. Here, we're considered obese, right? If we're in the top 18%. And this area is going to be 0.18, right? In terms of a proportion, if I convert the 18% to a decimal. So now that we're finished drawing the picture, right? We sketch the normal curve. I know the mean is equal to 28.7, and I know a female is considered obese if her weight is in the top 18%, or her BMI, not her weight. So now let's uncover the question, because I crossed it out because I said pretend like we don't even know what the question is. Now let's read the question. What is the minimum BMI of a female to be considered obese? So I'm asking for a BMI, right? I'm asking for a value of BMI, which is X. So I'm asking for a score, a raw score. BMI is X. So what is the BMI of a female to be considered obese? Well, where on this graph do we consider a female obese, right? Well, the cutoff is right here where I'm putting this X value, right? That cutoff between the top 18% and the bottom 82%, right? Because that's everybody else. That's where the line is, right? That's where the minimum BMI is going to be to be considered obese, right at that cutoff. So we're looking for an X value, which is a score. So this is, again, another example where we have to find a raw score. So we could use inverse norm. But when we use inverse norm, we have to input into the calculator the area to the left. So the area to the left is going to be 100% minus the 18%, right? That's the right. And this is going to leave us with 82%, or 0.82 is going to be the area to the left. So now we're ready to do inverse norm. The area to the left is 0.82. The mean of the distribution is 28.7. And the standard deviation is 1.4. And since like we said, since we're looking for a raw score, we're going to use inverse norm in the calculator. So let's pull up inverse norm. So second in the VARS key. Option 3. The area to the left is 0.82. The mean BMI is 28.7. And the standard deviation is 1.4. Now we could paste and enter. And we get about 29.98, which rounds to about 30. So X equals 29.98, which is about a 30 BMI. So this is the minimum BMI that a female would have to have in order to be considered obese. So 30 and above is considered obese. So a BMI of 30 and above is considered obese. So that is the last example that I have. And this was the final example where we have to use inverse norm to find a raw score. But before we end this lesson and start chapter 8 in the next lesson, I want to just write down on the whiteboard how to know when you're supposed to use normal CDF or inverse norm, because I think the main thing in this chapter that tends to give students trouble is in the calculator, how to know the difference, when you're supposed to use either function. So let me just go to the whiteboard for a minute. So we use normal CDF when we need to find an area under the normal curve given a z-score or a raw score. So we have a score, but we're looking to find an area under the normal curve. So the key word here is we're looking for an area. And we know the z-score or the raw score. So we use normal CDF when we need to find an area under the normal curve, given we know the z-score or the raw score. Now, if it's the other way around, so that we would use inverse norm when we need to find a z-score or a raw score given an area under the curve. So if we know the area under the curve, but we're looking to find a z-score, or a raw score. So basically, whenever we're looking for a score, but we know the area under the curve, that's when we use inverse norm. So that's the difference between the two functions. That's how we know when to use either one. So, you know what I think I'll do? Let me give you, I'm going to make one more lesson actually for chapter 7. So there's going to be one more, and what I'll do is I'll give two more examples, and then we're going to have to differentiate between what function we're supposed to use. And I think that'll really set the difference between normal CDF versus inverse norm. So one more lecture, we'll do one more example where we have to differentiate between the two.